Roger, copy.
All right. Hey, everyone. Welcome to another MoonDAO Town Hall. This week we're joined by Ian. Ian, he creates amazing YouTube videos that you guys should all watch. His channel is called AnthroFuturism, and it goes into essentially a lot of the key technologies that would enable a long-term human presence on the lunar surface. And he has hour-long videos where he'll go into depth about each of these technologies. Highly recommend that people check this out. I'm really excited to talk to Ian. One, because I love his videos, but two, because you know we, we have a lot of alignment around the order of operations when it comes to developing a long-term human presence on the lunar surface. He goes not just into the technology, but also into the economics of why you would do things a certain way, or what would motivate this type of technology and how it would decrease costs for future things. So yeah, I mean, I find Ian to be one of the deepest thinkers on a lot of these things, especially kind of like modern thinkers. Like there have been people that have thought about this for a long time. But what I like about Ian is he'll go in and do the deep research and pull up all of these old designs, but then also bring them into the present. So yeah, I guess before we get started, I'm just quick agenda. Yeah, we'll like usual do host this conversation, and then around the 40-minute mark, we'll open it up to questions. So if anyone in the audience has questions, feel free to write them in the chat. And then also we'll review proposals that have come in, and then project updates from the community. So great. Well, yeah, thanks so much, Ian, for being with us. Yeah, I guess just to kick it off, I'd love for you to just give us a little bit of your background, what kind of led you into this like video series. Because yeah, I mean, you've definitely taken a very deep dive, and I'm curious, like how did this idea even get planted in your mind? Where did it come from? So yeah.
Yeah, well, first, I'm just gonna say I'm glad to be here. I feel like I've known about y'all for a while, but it's good to finally like talk. We've kind of been like operating in the same space, like parallel, so it's good to finally make that connection. And yeah, I can't take all the credit for the work I do. I have a lot of people helping me, a lot of really brilliant thinkers and professionals in the space who all kind of, at first it was just me, but now that, when it started growing and snowballing, a lot of people got involved. So now it's kind of like a whole team and group effort. So yeah, how did all of this start? Well, I mean, where to begin? Like, I always used to just look up at the moon and be like, that's like right there. It makes sense to go to that right there. But I didn't really have like a lot of understanding of the utilitarian reasons, like hardcore uh, economic mathematical reasons as to why the moon is valuable or useful. It was kind of a notion of like, that seems like the next step. And then of course I was a big fan of like Isaac Arthur and things like that. During the COVID quarantine shutdown, I was experimenting with just making videos for fun. And I started making videos that were very kind of bad, but about the moon. And I kind of was like not trying to be a YouTuber or anything. I was just like, oh, I want to make some videos about this, and maybe it'll like, catch some attention. Just like, more content in the space, more eyeballs on this thing might help it in some small way. But a few of those videos like started getting hundreds of views, and a couple of them got a few thousand. And so I was like, okay, this is pretty cool. And I made probably 10 of them. And then quarantine lit up and went back to school. And, or I was still in school the whole time, but things got back to being busy. And so I finished with my first degree. I was doing like biological anthropology, like looking into human evolution, specifically of the brain. But to continue down that career path, I would have had to go to medical school, and I didn't want to do that, and I kind of don't like blood and stuff. So I instead opted to go back to engineering school, or school for engineering. And midway, like halfway through that, I was still kind of making videos on the side, but I really just, they were kind of all over the place. I did a lot of anthropology videos. Actually, that's where the name AnthroFuturism is derived from. It's like human future, but it definitely came from that time. But then I really leaned into like making lunar related scientific videos on like lunar development and things like that. So it was always just a hobby, and then the channel like started taking off. And I had a hard time managing both. So I decided to just kind of put school on hold and focus on the channel with the intent to go back to school. But that 2 years later, it's still going strong, and it's kind of bloomed into its own like career path in its own way. So now I do like research consulting on the side and stuff like that, as well as the channel. And I'm working on another book, which is going to be, it's like every video is almost like crowdsource. I'm able to like crowdsource scrutiny. And so just putting everything I've learned over the past like year and a half, 2 years into just a book. There's a big difference between watching a video and then reading something. You get a totally like completely different experience. So I'm excited to finish that hopefully within a few months. So yeah, that's that. Work continues. Right now I'm working on a video on coil guns. My last video was on rail guns. And so the other side of that is coil guns. And yeah, I'd really just like to talk about, try to like, the goal with this video is to try to sort of help people understand the magnitude that we're talking about when it comes to mass drivers, that they aren't a mega project. They're not on the same scale as O'Neill cylinders. They are, more or less on the scale of a pipeline. And it's not like a large hadron collider type thing. Like the thing that we built that is like the closest to a mass driver on Earth are particle accelerators, because those are a ton of like high powered magnets, in a tube. The reason those cost billions of dollars is because of the very sensitive instruments inside of them. It's not necessarily like the magnetic hardware, and it's still going to cost millions. But in general, whenever you compare a mass, it's like not fair to compare it to a pipeline, and it's not fair to compare it to a particle accelerator. It's somewhere in between, but probably closer to the pipeline. And then the impact of doing something like this, like establishing a mass driver, is massive. Talk about lowering launch costs. It's really like the step to advancing beyond this Earth. Whatever that means, if it means Mars or galaxy spanning stuff, whatever. It just very focused on the near term. That is how we can lower like the bottle. You can make rockets bigger all day, and that will have an effect. But the real bottleneck starts to become mass in orbit and refueling capabilities in orbit.
Right.
So yeah, that's.
Yeah. Okay. Well, like I love this direction, or like diving right into the technology. But I guess so there's kind of an order of operations, right, when it comes to developing this like human presence on the moon. What technologies need to be in place such that we can kind of create a mass driver semi-efficiently, right? We probably want some sort of like foundational ASRU or energy. I'm curious, what does that look like in your mind, or what are maybe some of those early missions before we get to the mass driver?
Yeah, so first we do probably want boots on the ground. There's a lot of what do you call it? There's like value in the perception of just returning to the moon. Like we could probably do this if we tried really hard completely with robots. Humans are super useful. But the question is, if we get boots on the ground, what do we do then? We get science, we study more rocks. Like, cool, I'm all for that. But what comes next? We need a plan to, like, we always talk about staying. We want to go to the moon and stay. But what does that actually look like? Are we just going to have, like, anyways, so you want boots on the ground first. And then what you want to do is, I would like to see like an action plan from boots on the ground in the first year or so of that to develop to a mass driver. And if you have that focus, it really helps you narrow in exactly what you're going to be doing with those boots on the ground. Right now, the ISS operates where it doesn't have. It's an awesome system. The ISS is like a laboratory in orbit, but they just kind of take like whatever experiments come to them. They don't have like a mission to go do something, if you know what I mean. Whereas if we had that on the moon to go build a mass driver, it would be like, okay, well, we need to figure out how to refine regolith. That's like the biggest capability that you need, because then you get your feedstock, and then it's like, how can we weld or fix? You know, you don't have to weld everything. You can make nuts and bolts. How can we machine these things into parts? How
Mhm.
can we center bricks? And so if you have that direction, then you can aim for something and you can figure things out along the way. And like a few engineers with a well-equipped, workshop is like an incredible enabler. It's like we talk about the seed, like something to start and turn it, to start everything. It'll grow into everything else. It's like, what does that actually look like? In my mind, it doesn't have to be, but the version that I sort of favor is like a few engineers with, like a CNC machine and some, refining capabilities.
Mhm.
And then after that, like it depends on if you do a railgun, it's both coil gun, railgun, both types are mostly just aluminum. So which is actually one of the harder things, one of the harder oxides to reduce. But if you can get that, then you're just a hop and a skip away from a mass driver. So
Mhm. So what sort of scale are you thinking here? Is it small enough that you could just ship all of it with a starship, or are we talking about refining the lunar regolith and creating aluminum right there?
well, it's hard. I mean, that depends on your plan. Most of the hardware you're going to need is to keep humans alive. And
Mhm.
that's kind of the benefit of trying to go without humans. But again, humans, talk to any like mechatronics engineer or whatever, like humans are very useful for like being the meat between the gaps of machines,
Yep.
like and then also kind of the brains when things break down. Yeah. So most of the hardware is that. I'm not sure if you could fit everything into one starship or two, but it's probably less than 10. If we had a very focused national effort to build a mass driver, I'm pretty sure we could optimize it quite effectively. um,
Less than 10 starships. Is that okay?
I estimate, yeah.
Okay.
Hmm.
And energy, I mean, are we talking about small scale, like these like small nuclear reactors, and just bring them with us? Or so I guess there seems to be like life support systems, and that's going to be a big chunk of mass energy, I assume, and then the raw materials to like build this. Is there anything that we're missing in the sort of like ingredients for or recipe?
Yeah, so the grid is like a very important aspect. It's not just the barrel of the launcher itself. We're talking tens to hundreds of megawatts, so it's
Mhm.
significant. Um, and so you could do it with importing nukes, but you could also like regolith has all the elements we need to make solar cells. So if you can make solar cells from lunar regolith, then scaling is not a problem. Scaling to those sizes is not a problem. We're
Mhm.
just talking about pasting solar cells. And that technology already exists. A lot of it was developed by Dr. Ignatiev at Lunar Resources,
Mhm.
and a few others have been looking into the space. So that's like, I don't know if I'd say solved, but it's like high TRL. And so yeah, the grid is probably the biggest unknown as to like the hardware that goes between the mass driver and the solar cells. You have like MPPTs and other kinds of hardware that may need to be imported, but it shouldn't be that significant. Life support systems, they take up a lot of space. They don't really consume a lot of power. Um,
Mhm.
but so yeah, and you can fit a lot of, and if you want to go completely ignore ISRU, you can fit a lot of solar cells into a starship. It doesn't just have to be nuclear, uh, because this thing can run just during the day.
Mhm.
And it freaks a lot of people out, but like it's still 50%. Like most stores and most industry, well, probably not most, but a lot of industry is still closes at night on Earth, and it's 50%. If you think about, one day, one night, 50% of the year it's not operating. On the
Mhm.
moon, people go, oh, 2 weeks of darkness. That seems like a lot of downtime, right? But it's actually the same 50%. You just have 2 weeks of daytime. And so, yeah, if you're really forcing the idea that you have to also operate during the nighttime, then of course you're going to have a lot more complications. But at first, and maybe that's something you can do in the future, but at first, like just solar cells, aluminum, you have a mass driver, run it during the day. And there's probably also benefits to like having periods of activity and then cool down phases for maintenance, for repair, for inspection. And then all the mass that you do have in orbit has to be like accumulated somewhere. So there's lots of logistics reasons that you might want to just run it during the day outside of, you know, strong, just like hourly production rates.
Right. Yeah, I mean, and I mean, this is a whole rabbit hole, but you know, surviving the lunar night does tend to be very difficult. I think with solar, the issue maybe that you run into is you have to have really good batteries and really good insulation. And I guess mostly I'm just surprised that this isn't something that like we can just crush right now. Do you have any sort of like in that mind in your mind, is that just kind of like solved, like no big deal, or do you think that will continue to be a challenge?
The
And
lunar night for humans
not
specifically, or
for hardware,
yeah. So I
kind of
mean,
thing, right?
right. So fuel cells are like one of the probably like if you can make batteries ISRU, they make sense, but fuel cells have a lot more power density. So if you're importing your energy storage, then you need to go fuel cell, but it's still like an extremely tall order. And if you're trying to run your entire industry at night, also using imported fuel cells, it quickly becomes unsustainable. If you can make batteries on the moon out of lunar regolith and stuff, then that works. Heat batteries, we have iron, we probably have nickel, not as much as they used to think, but there is nickel from like asteroids and stuff. And there's rust batteries, there's all kinds of things. So yeah, I wouldn't call it solved, but we have solutions. And night is just a much bigger problem for humans specifically, and it's part of their cost in general. Humans are extremely expensive, but super useful. So
Right.
yeah,
And so how long would a human need to be on the lunar surface in order to like boot up a mass driver? Because I mean, the radiation is pretty bad. Is that maybe like a little like sub step, is like create some habitat that has, you know, a ton of lunar regolith protecting these humans so that they don't you know
yeah,
deteriorate.
yeah, yeah. Probably you don't want to give everyone cancer.
Yeah, yeah, right.
But I mean, it's just dirt. Like
Yeah.
it's literally regular. We have mass everywhere for the radiation shielding, but it's a lot of shoveling.
Mhm.
So yeah, it gets more complicated because then you have to import like basically a front loader, bulldozer, whatever.
Mhm.
Um, and how long would it take? So that's kind of a question about like R&D, and it's hard to know. Maybe a year or two. It depends on how focused the effort is. It depends on how mature
Mhm.
our refining capabilities are and stuff from the time boots land on the ground with the intent to do that. In general, I think even with radiation shielding, they would probably rotate humans, uh, you know, once every month or so, especially if it's NASA to de-risk things. And that's going to definitely that will increase the amount of starships or whatever landings it takes to make this thing. It's kind of part of the human. It's like almost, yeah, part of the human cost. So
Mhm.
yeah, I would give it. I would just guesstimating. Take this with a grain of salt. 1 to 2 years if you had a very focused effort. Um, Probably 5 years, and this is like assuming starting from boots on the ground, focused on this. So
Okay. All right. So, I guess just maybe summarizing a little bit. So it sounds like you know, 10 to 12 starships kind of spaced out in a month long kind of cadence. You send astronauts in. First, they help build some sort of habitat, move a bunch of regolith on top of themselves so that they have some like protection, and then You have kind of like a steady supply of labor, of people that can come in, along with the raw materials each time, so they can bring the aluminum, etc. And then and in your mind, this can all be done in like a year, and which is incredible. I think most people don't. Yeah, they probably just don't realize that like something like that could be achievable in the time span of a year. Um, so okay, I mean, we can talk about the like order of operations and all the technology, but I also want to get to why a mass driver. So like, what are we going to be doing with this? How much does it reduce the costs of other activities in space? What are the sort of economics around it? I'm curious if you could just kind of lay that out for us.
Yeah, totally. So, where to begin? This is my favorite subject. So the moon is its mass in orbit. We spend so much money to get mass into orbit. Every satellite is mass in orbit. It's orchestrated matter. But it's actually cheaper to get, in terms of energy, delta V, to get from the lunar surface to low Earth orbit. Low Earth orbit is where the market is. That's where things are useful, and also geostationary and whatnot. But in general, near Earth orbit is where we want. The moon is very far away, but it's cheaper to get to low Earth orbit if you start from the moon than if you start from like Cape Canaveral, Florida. From ground surface, it's a 9 to 10 delta V. From the moon, it's I forget, 7-ish. But so you could think about this as, okay, so we make rockets on the moon. Because if you send a rocket from Earth to the moon and then it flies back and forth, it doesn't make sense, because you're actually doing, assuming it's 7, I'm probably misremembering that. It's like 14 delta V versus 9 from Earth. So it's actually more expensive. Plus, you can aerobrake on Earth. So you don't want to just send a rocket from Earth back and forth. What you need to start from the moon. And you can think about this as, okay, so we make single-use rockets on the moon, and we send them to low Earth orbit full of dirt, more or less, and refine it in low Earth orbit, or L5, and then we have tons of mass. But that's a really inefficient way of doing it for several reasons. There is not that much like liquid on the moon. We could try to do metal rockets and stuff, but that's quite expensive. And in general, you have the option. You don't have an atmosphere. You have the option to build a infrastructure which can launch your mass using electricity. This mass will still probably need a bit of a kick stage to circularize its orbit and to slow down. There's different ways to do it. So you're not just shooting balls of dirt that are completely unguided in general, although there are some proposals to do that, but they have very like narrow windows of time where that could be done. So I typically take the stance that less constraints is better. So the mass driver, the idea behind it is that you use sunlight to launch your mass. So not only are you getting less delta V, but you're also able to make up most of that leg with sunlight. So it's if we didn't have sunlight, it would still be a good idea to use some sort of rocketry or whatever. But since we have both, and we have and then in general, when you talk about for mass drivers on Earth and whatnot, they are more like mega projects, because we're talking 200-kilometer,
Right.
which we build train tracks that long, but the whole thing has to be like in a vacuum tube, and then it also it has to be either super tall. I mean, they become mega projects, but on the moon, because you have low gravity, you have no atmosphere, they become much smaller in scale and scope. So that's why you want a mass driver. And then why do we want regolith in orbit? Well, because regolith is oxygen and its mass, and that mass, you could reduce that oxygen or reduce that regolith oxide. You have oxygen for refueling any ship and station and satellite. And then what's left over is metals and silicon, which can be used to make solar cells or trusses and structures, or it could just be used as is, as like radiation shielding. You don't even have to reduce it for oxygen. Just regolith alone can be radiation shielding. So this allows us to build basically whatever we want. in orbit. There's so many applications, it's hard to even know where to begin. Just to name one, like Brilliant Pebbles is like the Star Wars program was started under Reagan, and it's basically like the idea is to build like a space shield to stop intercontinental nuclear missiles. The problem is it required way too much mass to ever be doable. And so the project was shelved in the early 2000s. But if we had a mass driver, that would be totally viable. So there you can like save the Earth from nuclear Armageddon. And then there's
could I is that's the first time I'm hearing that? Could you explain that a little bit more?
Yeah, Brilliant Pebbles. You can so you know how ICBMs, they have multiple like it's not just one warhead. They'll have like 8 to 12. It depends on the missile. They can have a bunch. Some of them can be dummies. They can have multiple warheads, and they'll all spread out. Mm-hmm. So you have to make an interceptor for like every single one of those. And then if you're talking about Russia or China or the US, these countries have thousands of missiles. So then inside of them, it's like tens of thousands of targets that would need to be knocked out in order to, stop a bomb from going off. So we have interceptors. You can find videos of these like little things that they have thrusters. They're pretty cool from the 80s. But the problem is just the amount of them required is staggering, just because launch costs are so high. But if you have mass in orbit, you can make. I mean, all you're doing is you're slamming something into an incoming ICBM to blow it up, right? Like mass in orbit, you can make. It's does that answer your question? Sorry, it's about scale, but there's so much more. I mean, there's other peaceful applications. I didn't mean to immediately go down a dark war path. It's there's telescopes and green energy and all kinds of things we could do with mass in orbit, so that we can't do now, or that is too prohibitive to do now. So cost prohibitive. You're right.
Yeah, sorry if you got echo there for a second. I was opening up the chat on Discord that we have. But yeah, okay, so that makes sense. So like, there's definitely obviously a need to have mass in orbit. There's a cheaper route of doing so. There's some upfront costs, but then afterwards, the delta V required to send mass from the moon into low Earth orbit is a lot cheaper. That all makes sense. And I think something else that's worth highlighting is in the Starship architecture. You need multiple of these starships for refueling, and that always seemed to me really crazy. But if you have a fuel depot that's just sitting there, and you have the moon that's supplying all of this oxygen, and all of a sudden that also decreases the cost of Starship's operation. And I remember in one of your videos you go into this. What could you maybe explain that a little bit more? Like what is the current Starship architecture? How much does this really decrease the total amount of cost? Because you laid out really well in one of your videos, but I'd just like to kind of pluck that out.
Yeah. So I should start off by saying, like, I don't keep up super close like tabs with Starship. I'm obviously hopeful for it, but some of the information I'm like pulling off the top of my head might be slightly outdated, so don't get mad at me, SpaceX nerds. But it's so in general, it takes, like, optimistically, 10 isn't very optimistic amount of, if you want. Okay, so Starship is really good at getting to low Earth orbit and just dropping off mass in low Earth orbit, so think Starlink. But after that, it's completely spent. Once it gets to low Earth orbit, it's empty. So you need to refuel it, and about 80% of the fuel is oxygen. Maybe it's 70%, but the vast majority of the fuel of a Starship is oxygen. And then refueling really matters more if you want to go beyond low Earth orbit, right? So if you think about trying to go to the moon, it's going to require about 10 more launches. So you have 11 total to refuel it, to get enough fuel for that Starship to then get to the moon. And then ideally you want to refuel it on the moon as well. So if you think about this very optimistic 100 tons number, and then you divide it by 11, it becomes like 9 tons, which is only twice as good as Apollo. So it is cheaper per ton, but the amount of tons has not. It's only doubled in what, 50 years,
Right.
and it's not even like done. So saying it's doubled is like assuming it's actually done. And if you think about like new Blue Origin's Mark II or whatever, like their ultimate goal with their lander is it's going to be around like 4 tons, 4 to 5 tons, which is what Apollo was as well. So we still sort of have that constraint. But if you can get a ton of oxygen in orbit from the moon, then you don't need 11 launches. You just need one,
Right.
plus the mass driver and everything. But that's how we reduce going beyond low Earth orbit, the cost of that. And there's a lot of useful things, beyond low Earth orbit. Sorry, I'm going to close my window because it's kind of
No, go
coming in.
for it.
Okay, cool.
Yeah. This also gives me a second to just say, anyone who's listening in Discord, feel free to ask questions or raise them, and we'll get to those questions at the end. So, post also on the YouTube video, anything like that. If you post comments, we do see those, and we'll go through them. Okay, so Ian, I guess not to put words in your mouth, but it sounds like to me that if you kind of go through this maybe somewhat painful process of setting up the mass driver, yeah, it's going to cost a lot, etc. But then all subsequent missions become a lot cheaper, especially if you're going to Mars and you need to send a bunch of stuff over to Mars. If you have this sort of scheme in place, then that actually reduces. It sounds like it reduces your cost 10x. So if you needed to refuel 10 times in orbit, and now you just have one that you send up and then you refuel it, that seems huge, right? Or maybe I'm off on some of that math. I'm sure it's not perfect, but is that kind of where your mind's at with this too?
Yeah, exactly. Okay. Yeah, and then if you think about like that's just focusing on oxygen. The shitty byproduct would be extremely useful metals, which would allow us to do anything we, mass space-based solar power, massive telescopes, space stations, brilliant pebbles, everything.
Yeah, I mean, sometimes I really like because it just seems so crazy to me that like we just happen to have this like perfect thing already in the sky that has all of the raw materials that we would need to get off of the planet, and it's just so like it's incredible that like the two major components of regolith are fuel, and then also all the stuff that we need to build stuff. So it's crazy. So that
it
also
seems like a tutorial level, or we're playing the game on easy mode. It's just put right there it's like a learning stepping stone right there. It's pretty crazy.
Yeah, it really is. And so okay, I guess when it comes to, I'm also fascinated with the idea of like building O'Neill cylinders or these like kind of mega structures in space. And it sounds like another like key unlock for all of that is just mass. And if you have a mass driver on the moon, now you also get kind of for free a bunch of raw material that you can use and turn into O'Neill cylinders or kind of livable habitats in free space, at the Lagrange points, etc. So I'm curious. People kind of fall into like 3 major camps. There's like the moon people, there's the Mars people, and then there's the free space people. What would you classify yourself as? Is it
pro Earth? Yeah, I think the moon is like a terrible place to go live, and space is like not great farmland, and Mars is like okay, like that's where if you want to build an artificial habitat or whatever, if you have to like carve oases out of the vacuum of space. Mars has a lot of the gases and stuff we would need, but in general, I think the Earth is like a beautiful breadbasket that we should grow from and then like preserve. And so the moon is mass in orbit is how you do that. But yeah, you could build O'Neill cylinders. That's why O'Neill is the first champion for mass drivers. Totally. Like it's not my idea; it's a very old idea, and it was a pretty big idea in the 70s and 80s. O'Neill got NASA funding to do it. He did three. He did. I forget if it was one big study, but he developed a lot in the mass driver, and then Sandia Labs and UT took up the mantle, and it's kind of just been this continuous thing. But we really forgot about it in a lot of ways because it kind of went to weapons applications programs and things like that. But in general, like that was why he was a proponent of a mass driver, because that's how you got to his like stations. And I think that's also like an accident. Like he obviously didn't intend this, but I think a lot of people think of mass drivers as a mega project because they associate them with like O'Neill cylinders, which if you've read The High Frontier is not just about, he had a lot of like early stage small space stations and wet workshops and things he was proposing before math, but everyone remembers the O'Neill cylinder, and then they lump that in with mass driver, and so the two kind of become this mega project umbrella that yeah, it's kind of an unfair remembering of his work, but
yeah, no, totally agree. And yeah, I mean, I think for the record, I'm also pro Earth. I think Earth is by far the best spot.
Yeah, that was a little sarcastic, sorry. Yeah.
No, I think well, people they have, I guess, like the misconception that like all these space people, you know, they want to live in space, but I mean, space is going to be incredibly harsh for a very, very long time. I think more of it is like you just want to preserve Earth and keep Earth, you know, a little oasis, so that we can continue to expand as a species and not have to have any of the sort of like degrowth stuff that seems scary to people, seems scary to me. But if you have all these resources in space and you can move a lot of the heavy industry off world, like it seems pretty, you know, makes sense to me.
Yeah, I mean, yeah, space is like how we make life better here on Earth. Because like, I mean, if you just think about like the standard of living is directly tied to like the amount of electricity that we consume and stuff like that. And if you can have like bulk clean electricity anywhere on Earth, I mean, there's other ways to do that besides, you know, there's fusion and there's superconducting stuff. There's other ways to do that besides space, but space is like a massive enabler of quality of life here on Earth that we don't even think about. Like how much value do you get from like your GPS, you know, like the internet, like we're doing this because of benefits we get from space. And so now imagine the benefits we've gotten from space just over the last 20 years. And going back to the 90s, we didn't have any of this. And then if you think about like 100 times that, what life would be like for the average person here. So yeah, we get, and then if you're just talking about existential threats and like great filters, like mass in orbit is how you stop, you know, nuclear Armageddon, but it's also how you can like stop asteroids, and you can build giant asteroid tracking telescopes and things like that. So it allows us to really like take control of our destiny and not have like these, you know, calamities or whatever outside of our control.
So. Absolutely. All right, so let's assume that the audience is convinced now. I'm convinced we want to have a mass driver on the moon. What do we do about it? How do we accelerate this? How do we make sure that it actually happens? Do we go lobby NASA? Do we start a new startup? Do we like what are the actionable sort of steps that you see? That, I mean, you're doing a good job right now of even just articulating this vision of telling people, hey, this makes sense, and convincing people and getting the buy-in. But okay, we're bought in, now what? What do we do?
Yeah, well, that's kind of the big question, isn't it? I think we could do most of the work on Earth, actually. So like refining regolith experiments or something that's something I'm very invested in and interested in and trying to help enable through the channel. So that when you get there, you don't have to like figure out how to refine regolith. We already know how to do it. And then if you can get a lot of these technologies can't be tested on the moon until you're on the moon, but you can get them very mature before you go there. I think right now, yeah, it's hard to know if a private company or nonprofit could have enough funds to pull it off on its own. That's a big question because it's hard to know how much funds would be required, how much capital. It's probably around $1 billion or more, just a guess. You know, not a financial guy, so I don't know. But
Mm.
that's the problem, is it's like it's not a big deal for the government to do, but it's a big deal for the government to become interested in doing that. Kind of the public facing side pressure, like even like just keeping Apollo alive was a lot of work back then. We all know the government. But it's a tall order for like a company to do. So there's this gap where it needs to be fulfilled, to kind of lower that
Yeah.
bridge.
You th
Um,
you say a billion? You think that
Well, I don't know. It could be on the order of probably less than 10 billion, probably more than one. So, but I'm not sure. I haven't run the numbers on a mass driver specifically. I think a moon base could probably be done for around 500 million. But again, all of this depends on like how much profit people are trying to make off of it, and you know things like that. So, you know, uh, but in
well,
general, sorry, go ahead.
well, it just yeah, I'm curious what the total amount that's gone into Artemis looks like, and where that
Yeah.
money or the bulk of it is going, and because Artemis's budget, I actually don't know off the top of my head, but I think it's north of a billion. Um,
Yeah, it's
and
over
it's
11. I think it might be nearing 12 billion. So,
geez,
yeah. Well, I mean, think about like how much cheaper Starship costs to develop. I think Starship might be around 2 billion or something like that.
hmm.
I forget.
In
Again,
total.
don't.
Okay.
Yeah,
Yeah,
I'm not sure. It's definitely like less. I know that Artemis is a lot more, and it's also like 12 years old. Um,
right.
so, but
Newsflash.
yeah,
The government should not be doing this.
yeah,
Maybe.
I think NASA can play a very nice support role, but I don't know if like they're going to be able to do it. If they were to do it, it'd probably be very expensive.
Right.
If they were trying to do it in house or whatever.
Yeah, I mean, my tricky thing for me at least is like, I think we should increase the total amount of like capital that's allocated from our like national budget towards space, but then it seems to me that the way that we use those funds is currently incredibly inefficient. So, um,
Yeah.
the but
Also, I want to. Oh, sorry.
oh, go ahead.
I
Go ahead.
wanted to point out, if you could build one mass driver, you can build 10. Like if you're investing in the ability to build these things, you're not investing in one.
Mhm.
So even if it's like 10 billion, that you can build 100 of these things once you build one.
Yeah. So, if we look at like the total amount of money that SpaceX or Blue Origin has at their disposal, and maybe we're at least within an order of magnitude of that 10 billion. Maybe it's 100 billion, maybe it's less. Who knows? But somewhere around there. That seems doable. Like
Yeah, it's totally doable. It
they've
was
got a lot.
doable in the 80s. Like we could have done it. It would have been more expensive, but we did Apollo way before we probably should have.
Yeah,
This is
yeah,
not using any advanced technology. It's using stuff that's decades old.
right, right. But I guess we still have to have the like more fundamental technology of just having like this like low cost to orbit, because obviously until you get something like a mass driver, you still have to do all these refueling steps, and yeah, that's just going to be really really difficult. But okay, I guess like kind of grounding it in the present. So if you look at where we are today, um, like what say okay, now we have so okay, we have buy-in, we have the plan, we're starting to take steps towards it. What do you think would look like a realistic timeline given the sort of like technology readiness levels of like each of the steps that we've talked about?
Well, if things continue at their current level of interest, probably 2100. But if we can accelerate and focus and get people, funded, um, most technologies are around TRL4.
Mhm.
Um, if there was like a national focus, or even just a very, yeah, if like, if I mean, Blue Origin's obviously doing a lot of good ISRU work, so I don't think we'll be 2100. I think, uh, if there was a really concerted effort, then it could definitely be done by like 2045. So we could totally live to see it if we like tried. You know.
Even 2045 seems slow. I feel like we could do it. We could do 2035. I think.
Well, I think my 1 billion number was so low I had to go higher on the time scale. So.
Yeah. Yeah. I
Yeah.
mean, yeah. I don't know. It's hard. It's hard for me. It's so hard to estimate these things, and so hard to like figure out. But it just blows my mind how we were capable to go from um, when did Kennedy give his speech? Is it 1961 or 62? And
Yeah.
then not even 8 years later, we sent someone to the moon. Yeah, I think you're right. It's really just about this sort of like national focus and whether or not we can get people as excited about it as like we were in the 60s about going to the moon. Um, but yeah, I guess that requires like really, really good leadership. And I'm optimistic with Jared Isaacman. I think he's a great communicator. He inspires people. I think that people could get behind a vision like this. Yeah, I don't know if you want to comment on any of the sort of like NASA political stuff, but do you think that we can garner maybe the national will to like do something like this? Like, do you think that our culture is stuck? Do you think that we're too nihilistic about space, or I don't know? Do you think that we can turn it around?
Yeah, at times I do feel nihilistic, but then I always meet people and find things that have happened that there's still a lot of like good faith operators in our society. So I am optimistic, but ask me another time and I might give you another answer. But in general, I think we can do it. And I just think that there needs to be like strong leadership and a strong message. And again, like we had all that with Apollo and it was still just like very close to being canceled so many times. But I think if people understand the importance, and it also, you don't necessarily need the entire public to be on board. Like the world's held by small teams of hardworking people doing incredible things. So you don't really need the entire public to be sold on something. You just have to have, enough resources in the right area for a long enough time. And so that's kind of why the numbers are hard too, because it's like, yeah, if the government's doing it, it's going to cost a lot more. If it depends like what avenue, like some avenues of approach are so much more efficient than others, how companies do things and companies have their own flaws and drawbacks too. Like they won't put money into things that are not profitable within, 5 years. And a lot of this stuff is not profitable within 5 years. So you need the government to kind of step into that gap. And I'm hopeful that NASA will start focusing on, a mass driver. That would be awesome. I don't know if they will, but we'll see.
Yeah. Yeah, I mean, it sounds like there's renewed energy or focus around the moon, which is great. I saw one of your videos, and I remember when Elon said this too, that the moon is a distraction, and that was like pretty concerning. I was like, oh, like here's and it really doesn't have to be a competition. Obviously, like we outlined, like if you can get some of this infrastructure in place, and that enables more mass to Mars. So
Yeah. No, totally. I saw that too. And yeah, it's there's like this beef, this rivalry between Moon and Mars people, and there really shouldn't be, because we're both like definitely like in this together, and the space is like threatened in general, and so we should really like unite and figure out our differences later. But right now we have a common enemy, which is degrowth, and detractors and stuff like that. So yeah, and the moon is definitely not as, I felt like it was pretty irresponsible that he said that, but I also kind of, I don't know, I kind of understood where he was coming from. He's very like focused on just like trying to get that second lifeboat going, but I guess he didn't do too much thought before he tweeted that, like most tweets go. And it seems like he's a lot more friendly towards the moon nowadays, so that's good to see. And it's totally okay for people to be wrong and then change their mind. So yeah.
yeah. No, I think he's definitely changed his mind a bit on the moon. I remember, yeah, once I it was kind of one of these like kind of very surreal moments. He was like Elon was streaming some video game, and there's like an active chat, and I threw into the chat, like basically this question, like, why is the moon a distraction? What And his response was basically like, yeah, during nuclear Armageddon, it would be easy to nuke the moon, but it'd be difficult to nuke Mars. So I think he really was thinking at the time in terms of like annihilation of the human species, which, if that's what you're optimizing for, yeah, you want to get as far away from Earth as you possibly can. But hopefully the timescales have sort of extended on our nuclear Armageddon. I think at the time it was very pressing for him. This was like,
Right.
2024 when things maybe seemed a bit more bleak from his perspective.
Yeah.
So
Well, and maybe we should tell them about Brilliant Pebbles. And
yeah,
also, yeah, it's interesting. Like on the moon, in space in general, nukes are like way less effective because they're still very powerful. Don't get me wrong, but a lot of the destruction from a nuke comes from pushing the atmosphere, and it's like the atmosphere hitting you that like rips your lungs out of your mouth and shit like that. But in space, there's no atmosphere, so it's just like a good bunker busting. But also, like every habitat in space is kind of a bunker. Um, he's right though. I guess the moon is easier to nuke than Mars, but I don't think that's a great reason to ignore the moon.
yeah, no, for sure. I think yeah, I'm optimistic that our timeline for nuclear Armageddon is more than the 10 years that it would take to make the mass driver.
Yeah, definitely.
It sucks to put things in those terms, but yeah, I guess the P Doom for me is I don't know. But anyways, so we're almost here at the hour. We do have a couple questions, so I do want to get to them. So let's see. Kent asks, are there any known lava tubes near the polar regions? Actually,
Not that I know of. I don't know lunar geology that much. We actually don't know. We're looking into more missions to sort of map lunar lava tubes. We don't know a ton about them. We know they exist. We're taking pictures of them, but we'd never sent like something in them. We were going to, but that mission got canceled. There's others that are looking at doing, like ground penetrating radar and stuff. So, but as far as the poles go, I'm really not sure.
yeah. I guess just to linger on this a little bit more. So if we were to build a mass driver, does it make sense to put it near the sort of like peaks of eternal light, where you can kind of get 24/7 access to sunlight, or is there another spot? Have you looked at this problem? Is there another place that you think would be better?
Yeah, good question. I think the equators actually make sense because they're flat and it's easy to build on flat ground. Uh, yeah, there is a bonus to having those like eternal light, but if you look at the actual like maps of where the eternal light exists, it's like in pretty narrow slices, a few kilometers across, very large for a human-sized, a little outpost, but not big in terms of a mass driver. And they're kind of like on top of if we're talking about building a pipeline, it's harder to build it on top of a mountain or on top of hills than just on flat ground. So I favor the equatorial regions for that. Also, well, yeah, but I mean, there's other. It's not really a definitive thing. There might be advantages to doing the polls. We need to go to find out, and we need to send more missions. Yeah.
Yeah, yeah, yeah. I mean, I think in general, like people feel like there's a lot of data that we're like working on when it comes to the moon, but really it just isn't that much. So,
Yeah.
and I realize actually as you were answering the question, do we talk about the length that you have in mind for this mass driver? You might have mentioned it, but I think it might have slipped my mind.
Yeah, I mean, rough calculations. There's lots of different mass driver designs, but for one, that's a reluctance launcher that's a 25 centimeter diameter barrel. It can probably launch around 140,000 metric tons of regolith in 1 year
Wow.
if you have a 3-second cadence. And in general, so take these numbers with a grain of salt, but that would be about 3.5 kilometers long. You have everything ranging from 2 kilometers to 100 kilometers, but in general, it's around 10 kilometers or less. But you can trade power, like the amount of electricity that you pump into it, for length. So if you're really like, it depends what your limits are. If you're terrain limited, then you're going to want a much more powerful system that's smaller and shorter. but that means a bigger grid. And if you're using solar cells, that's still a larger surface area. That's why, the equator seem sort of attractive because it's flat, and so you don't really have to worry too much about this. And there's no like NIMBYs on the moon, yet. So building it should be easier than the California high-speed rail. So
You'd be surprised though, because I don't want to name everything about this, but we were working with a partner, and they wanted to send some biological material to the moon, and the White House received a letter from the Navajo Nation saying
right.
that we do not allow this, because the moon is sacred to us. So in some ways, the moon is in everyone's backyard. So
Yeah, I do remember that. Yeah, that was
yeah.
very frustrating. I thought about making a video directly about that, but I was like, I'm not gonna react. Don't play in the mud. That was frustrating though. Yeah.
It was, yeah. Yeah, I mean, and it's really hard. Yeah, it's hard to push back against that. But yeah, I mean, I'm very curious around some of the. I'm not as interested in the sort of like political side of the moon. I know a lot of people are like interested in like the space law aspect of things, and I think that's gonna play a role. But yeah, I think anything that's built on the moon will be very controversial. So
Oh yeah,
they're ready.
for sure. But I mean, if we don't do it, someone else is gonna. So
Right.
you
Yeah.
know, it's also yeah, and it's kind of the same with space law. Like, and what power do they have to stop you? So that is the benefit to. I think a lot of space law is putting the cart before the horse, just because to enforce the law you have to have force in that specific place. And that is why, like, if the White House can stop a mission, public opinion does matter. You can't just have like a rogue organization go do this and then they'll be shut down. So you might not have to have 60% of the nation on your side, but you have to probably have at least a majority that supports it.
Yeah.
Mm-hmm.
Yeah, that makes sense. Yeah, I mean, I think we'll have to win hearts and minds as well. I can't just go and enforce our will on the Earth. Type 2 Labs, so they're a really cool organization working on some really interesting stuff. They say they're pro mass driver. That's great. People should check them out. Type 2 Labs. I don't know if
Awesome.
you're familiar with.
Mm-hmm. What do they do?
So, well, I don't know how much of it is public or that they want to talk about, but essentially they have methods of like engaging the public with space missions that are really, really cool. But I don't want to give away too much about other stuff, but people should check them out and go to the website
Awesome.
and stuff. Cool. I think we have something in the Discord, but I'm not sure if it's a question. It's somewhat long. Okay, it's kind of a question. All right, I'll read this off. It's like a paragraph about compute. So Matt says in the Discord, many people like Musk are starting to frame space as the next compute frontier, offloading energy-intensive computing to orbital or lunar environments. From your lunar perspective, what is your view on extraterrestrial compute? Do you see the moon becoming part of the global compute fabric, whether through energy, cooling advantages, or governance?
Yeah, well, that's a good question. So the biggest like bottleneck with compute is the electricity consumption, right? In space, there's tons of free energy. So the advantage is that the problem is cooling is harder in space. You have to build large radiators and things like that, much larger. Because on Earth we get free cooling from the atmosphere or rivers. But we also don't necessarily want a ton of like data centers just like consuming our water resources. So there are benefits of putting data centers or compute in general in space. I'm not sure it's extremely near term. A mass driver would be a great way to do that and scale that because you need mass to do that. The delay between Earth and the Moon is 7 seconds. Realistically, it's not. It's not really 2. Everyone says 2, but it's like practically 7.
Mhm.
And it varies depending on where you are. I don't know if that would be a big bottleneck, but it's something worth considering for data centers on the moon specifically, but data centers in orbit around the Earth, those might have some big benefits. And a mass driver is a great way to do that, you know. So
Mhm.
so yeah, I guess, yeah, I don't really know what to say more than that. That's all I know. I don't know, but you know, computers. I'm not a computer guy necessarily. I know computers, but not super in depth. So
Yeah, no, I feel you. I also struggle a little bit with the idea of compute in orbit or compute on the moon, mostly because just there's so much kind of like random maintenance involved, and so you know if you have something that's so far out, like it needs to be incredibly reliable, and I just feel like um, maybe in some sort of abstract way it's like it's a really great use case because people will spend like you know billions of dollars on these projects, and then also it is a way to serve earth, and eventually you know a lot of the like business models, like the customers are on earth, so like you need to make something that like serves earth, so it kind of checks those two boxes, but yeah, I guess I'm just not familiar enough with the actual like um, technology, or how they intend to do this in a way that's like so reliable that you don't need to send a maintenance guy up there.
yeah, and that's another benefit to like having them in orbit is it's like a few hours versus a few days. You know, you can get to the moon in a few hours if you really go fast, but it's much harder and more dangerous. Anyways, yeah,
Hmm.
yeah, and you can also keep the data centers on Earth and then beam power from space if you want to do that. There's options. So
Right. Yeah. Yeah, that stuff's always been very interesting to me too. The like energy beaming from space to Earth. Yeah. I'm
mhm.
curious if you've seen like what are the most practical sort of ways that you've seen that. As I've seen some stuff where it's like you can buy daylight and like for like agricultural like oh yeah now you just have like a massive mirror in the sky that like just beams sunlight to you, which is pretty cool. Um, but yeah, I'm curious what why haven't we seen this, like because people have been talking about it for a long time.
Yeah, well, I mean, solar cells got extremely cheap on Earth, and so those kind of displaced space-based solar power. But I don't know. I don't think space-based solar power is out of the race yet. There's also obviously like increasing nuclear efforts, you know, small modular reactors and whatnot. So there's a lot of ways we could solve our energy problems. What space-based solar power has going for it is unlimited scalability. So we're talking about like mega, like multi terawatts. Uh, we'll run out of like uranium and stuff eventually. So especially, actually, it's like pretty quick if you do the math and you're like, okay, if everything started using nuclear right now, it'd be like a few years, like 10 years before we just ran out of, you know, fissile material. Fusion would be awesome.
Hmm.
And then like I was talking to a Dr. Jeffrey Landis, one of the like pioneers of ISRU and space-based solar power, and he mentioned like even things like superconducting cable, like long distance superconducting cables, might push space-based solar power back further,
Hmm.
because then you can have you know, massive solar farms in like Nevada and then send the power to Alaska
Right.
losslessly. Um, so it's, but there's a lot of massive, like very, there's a lot of advocates for space-based power as well. And to be honest, I'm kind of neutral. I think that it is promising in terms of scale, but I can't say definitively if it's like a good or bad idea. It has a lot of near-term competition, but ultimately I think it probably will play out, but I don't know if it's like, you know, something to aim for right now.
Right.
Yeah.
Yeah. um yeah, it just seems like one of these things that's like, oh, this could be really useful today, but yeah, I just wonder what's in the way. Yeah, I guess it's just not cost effective.
Yeah, and it might be useful for smaller scale applications rather than like industrial overhaul. So like being able to beam electricity like to a forward operating base or to a ship or to a remote weather station in like Norway or whatever is like there's applications for that. that you can use space-based power for. And we're not even talking about like sending light. Like you could use a laser, but you can also use like microwaves and things like that. The problem is like, and I don't want to speak too much on this because I don't want to like speak out of my lane and say something wrong, but you sort of have to create like no-fly zones, which might be fine. But you're talking about like sending microwaves through, the atmosphere. People are already afraid of their Wi-Fi routers, so it's sort of contentious, and you do run up against like the public scrutiny a lot faster there. I think if you
Yeah.
just think about the history of nuclear power. So
Yeah. Yeah, it'll be hard to get away from like the microwaving the earth narrative.
exactly, yeah. And
Yeah.
what about the birds and things like that?
Yeah.
Especially for high power, but for low power, it should be fine. Like it's just a slight warming, which might be nice in Norway, but
Yeah.
yeah,
Just, toast them up a little bit, they seem
right.
to. Cool. Well, all right, we're just past the hour. This was awesome. I get to talk about all my favorite stuff and get to put all the hard questions on you, and you did a great job. I know like some of the questions I was asking are like kind of ridiculous, like or just very difficult to come up with concrete answers about, but I find that you're very good at reasoning through uncertainty, because obviously there's kind of like there's a lot of stuff we don't know right now, but like I said at the beginning, I think that you've done an amazing job of like taking a lot of these ideas that have been, almost forgotten, and then shedding new light on them, and modernizing them in many ways, and so I just want to thank you for doing that, and putting together, I guess, an amazing team of people that are kind of reasoning about all these things and debating it and kind of sharpening the ideas. I think that's really cool. So thank you
Well,
for
thank you. Yeah.
doing it. Yeah.
Thank you for having me. It's been a lot of fun, and this is my favorite thing to do and talk about. So, should do it another time if you're open to that, and I appreciate it.
Yeah, absolutely. Yeah. We'll have to check in after you put out your video, as I'm sure you didn't get to all of the stuff with the mass driver. So yeah, when will that come out?
Oh, probably within a week.
Okay.
Yeah, I'm almost done with it, but
Okay.
yeah, hopefully before Thanksgiving.
Okay. All right.
Mhm.
Well, we'll definitely share it in the MoonDAO Discord, and we'll maybe try to get a little discussion thread going, and maybe we'll watch party or something. It could be
Awesome.
awesome. All right. Well, yeah. Thank you so much.
Yeah, thank you.
Yeah, feel free to stick around. We're gonna move into project updates. So for context, every week, all of the people that are leading different projects in the MoonDAO community. So the MoonDAO community funds different projects, and then we basically update the community on the progress and how they're going, and figure out how we can support them. So yeah, cool. I will kind of pick someone here at random. Hopefully, we can get, maybe let's start with Frank. Cool. There we go. Perfect. All right. Thank you, Ian. I'll bump you down here. And hey, Frank, how you doing?
Hey, Pablo, how are you?
I'm great. I'm great. Yeah. Did you? Yeah. Any thoughts on the conversation with Ian, or? uh, yeah.
Yeah, it reminded me of the old days, to tell you the truth.
Yeah.
Back in the day, I was involved with Gerard K. O'Neill, and we talked mass driver all the time. I mean, it was a big idea that he had, and there's a video somewhere of a test run of a mass driver at Princeton, which it was pretty remarkable that it happened back in the day. And I really haven't heard anybody talking about mass drivers since those days. So that was interesting. Fascinating, actually. And I thought it was interesting that you all were talking about the very different options for living off world. And also, I totally agree with the idea that we have to think about people living off-world as a benefit to Earth, not
Hmm.
an escape. And that's a philosophical approach. And I'm a space philosopher, so you either approach it as an escape or as a benefit to the planet. So it's not just an abstract concept. It really will be one or the other approaches. So I thought that was a point well made.
Yeah. Well, yeah, it's awesome that yeah, I would have loved to be a fly on the wall in those conversations between you and O'Neill on mass drivers and all the stuff that happened there in Princeton in what the 70s and 80s. And yeah, it's awesome to hear your perspective on that. And I'm saddened in a way that the conversation hasn't continued or that there's been a lull. But yeah, hopefully people like Ian will lead the charge towards mass drivers and we'll yeah. All right. Well, yeah. Would you like to give us a quick update on the project and things are going and how people can support you? That'd be great. Mhm.
Yeah. So as you know, the project is a planning project, November, December, to take a look at the bigger project, the overview effect comparison project, and to take some steps in the direction of the bigger project, which is really involves going on space flights on the different carriers and seeing how they produce the overview effect. So uh, I had 4 goals that the community approved. One was to develop a plan for fundraising, which you know about. And so there's a first draft of that, which we'll be talking about soon. Second was to talk to the different carriers, get some idea of cost and schedule, and that's pretty well complete. There's a late addition to that, which is that there is a stratospheric balloon flight potentially connected to the eclipse in August. I'm looking into what they are up to. The date is pretty well set. It's going to be when the eclipse happens. And so I'm looking into that as another option. Uh, the third, the third goal was to get soft commitments toward the cost of the project, and the tentative goal was $100,000. And I've talked to several people. I've gotten really good responses to the idea. So I'm about 10% of the way there at this point on that. And I'm finding it's getting easier to ask the more I do it. It's hard the first time. And then finally working on some type of a kickoff video to launch the fundraising. So I haven't really done much work on that. I have a first cut, and I'm going to upgrade my capability on that and see if I can produce something better. But at the moment, I'm happy with the progress and I'm happy with the reception I'm getting from people. Yeah, if people in the MoonDAO community want to help, I think I would really enjoy having assistance on securing these. I'm calling them aspirational commitments rather than soft commitments, but basically, what do you think you might be able to give toward this project? And if anybody has friends or colleagues, or if they themselves want to do that, it would be nice to reach the $100,000 goal.
Yeah. Yeah, that'd be awesome. Yeah, maybe we can share a link to a form or something like that where people can put in aspirational commitments
Of
or
course, yeah.
yeah, I think that would be great. Okay. Great. Anything else to share, Frank?
No, I just want to thank the community for their support, and you and Ryan for your support. This is a challenging project. Actually, The short project that we're doing right now is pretty straightforward, but the larger project is challenging, and it's very good to have support and for people to think this is a worthwhile effort.
Definitely. Yep. It's the yeah, it's like well, this project is really the launch pad for the bigger one. So
Yeah,
get everything really really worked out now, then I think that'll make the what seems to be very very difficult a lot easier. So
yeah, for
yeah,
sure.
awesome. Well, yeah, thank you, Frank.
Thank
Uh,
you.
cool. All right. Well, I will get the next speaker up here. Great. We've got Wonder of Me. All
Hello,
right. Hey, how's it going?
it's going good. Yeah, I just want to. This is actually my first proposal ever. I'm pretty new, so
Oh,
I
sorry.
yeah.
Actually, so I didn't know that you're putting in a proposal. Actually, let's
Oh,
wrap
my
up
bad, my bad.
with the project updates. I'm sorry, it's my fault. Let's wrap up with the project updates, and then we'll get to the proposal. Yeah, awesome. Thank you. Yep. All right. Sorry about that, guys. Cool. We'll continue here with Roy. Hey, Roy, how's it going? We might not have Roy here at the moment, or if he's fishing for the unmute button. Roy is representing the Lores project, which has just recently passed in the community. Congrats to Roy and others in that project, including Rod, who's been a long time contributor to MoonDAO. They're working on an open source standard for lunar rovers, which is really cool. And yeah, Roy is leading the project. Although I'm not sure if we have Roy here, so just give it a second there. All right. Well, yeah, I think we might have lost Roy. So we'll actually go back to Wander of Me. Sorry about that, guys. We'll keep moving forward here. Hey, and you're back. Sorry about that. Just had to check in with the last project, and but yeah, go ahead.
All good.
Hear
So
your yeah.
well, my proposal is a weekly summarizer for meetings like this. So the weekly town hall is 1 hour long, which is a big time commitment for a lot of busy members, and it's easier for a lot of people to fall out of the loop and feel disconnected. So that creates a gap between active members and the rest of the community. So I built an automated summarizer that takes the YouTube video and then transcribes it, then basically makes a summary and emails that to everyone who subscribes. So yeah, that has already been created. I'm going to do a display after the presentation. So the proposal is I'm asking for 1.25 Ethereum. This is for the compensation for creating it in the first place, which I have already completed. And then for maintenance, I need to weekly I need to run it and then verify and manage the service for Q1. So I was able to speak to Ryan and Rod, and they suggested that I integrate some existing infrastructure, so that will reduce the prices of the cost of it. So I'm going to do a demonstration. If I mean this isn't going to be relevant anymore, this part I'm showing, because we're going to use the new subscription. People don't need to subscribe anymore. Well, let's say someone subscribes right now, right? They could go to right now it goes to their email and then they can just confirm their subscription. So this is the admin panel. I could do this, and it's password protected. I could either get the link from here of a past town hall, or I could manually paste the transcription. So to save time, I'm going to paste a transcription that I already got from last week, because manually from using the link will take a bit of time to download the audio and all that. So when I post the transcription, I can just generate a summary. This calls Gemini's API, and then it summarizes the transcripts. It takes a few seconds. All right. So I can then inspect the summary, and I can alter it in any way I want if I feel like it's not informative enough. And then I can regenerate or send it to everyone. So this is going to send to everyone who has signed up a summary of the meeting. Oops. Okay. So everyone gets a summary of the meeting, and they don't need to feel disconnected. And yeah, that's it. So yeah, that's the proposal pretty much. Yeah, it's a way for people to stay connected to the meetings even if they are not present. Thank you.
Awesome. Well, yeah, thank you very much for presenting. So I'm actually not sure if this proposal. Oh, great. It is. Yep. So there's a thread in the Discord for Senate members to vote. I will tag people there in the Discord. So senators, you should have received a notification just now in that thread to give a temp check, thumbs up or thumbs down. And if anyone has questions, either in the Discord or on any of the socials, feel free to post, and we can ask here. On any of the socials, feel free to post, and we can ask here. Got a little bit of feedback there. I don't know if you guys heard that, but just trying to open up the Discord thread here. All right, so we'll give it a moment. But yeah, I guess just to give some thoughts off the top of my head, I think that this would be useful and something that would be helpful in the weekly newsletters that we send out. And if people are not already subscribed, you can easily subscribe to the MoonDAO newsletter from the website. At the bottom, there's a place where you can add your email and join our newsletter. Yeah, that said, this could also be a great candidate for a community contribution. So oftentimes for things that are set up one time and then we basically have a reward cycle that we run every quarter, and then people in the community can reward different contributors directly. So they don't have to go through a proposal process necessarily. And yeah, it might be a speedier version of getting rewarded for this work, and we can integrate it in. But yeah, it doesn't seem like we're getting any questions in from the Discord. So yeah, I just make sure Senate members to react in that Discord thread, and then if it passes the temperature check, then we'll put it up for vote in front of the community on Snapshot. So yeah, thank you very much.
All right, thank you.
Yeah, all right. And great, we actually do have someone from the Lures team that can join. So we've got Rod. We'll head up here on stage. Hey, Rod, how's it going?
He, actually, Roy also should be available. Could you put him on stage? Sorry for the mess.
No worries. No worries.
We're just
Hey, Roy.
learning how things work. Cool.
Can't hear Roy, but we're hearing you, Rod.
Yep.
And yeah.
Okay.
Yeah.
So the proposal passed, I believe, on Tuesday. So it just been a few days. we are establishing initial operations. Thankfully, we already have a GitHub. It would take us some time to figure out the processes with the GitHub, how to interact with the community. Also, Alexa, one of our team members, he joined Bremen. If you do not know, in Bremen, Bremen, it's a city in Germany, and every year there is a huge event happening there. Seems like this year was really huge. So there were several rovers, I believe around 4 or 5 projects at different stages. And actually, one of the project is called ORS, Open Rover System, or something like that. But it's not open source. But like they pretty aligned with the idea of modular rover, and they're pretty developed. They started in 2020 or so. We'll put all the information about the projects that we found on GitHub. Also, we got several people from MoonDAO community interested in helping. So hopefully, in the next couple of days, we will establish processes. In terms of what's needed, any help is much needed. However, for a while it'll be a bit a mess. So if anyone is interested in helping, I encourage everyone to join the channel that is called Lors on MoonDAO Discord. And if you do not know how to join there, please tag me. I think that's pretty all. So not much to update. We just started.
Great. Okay, well, yeah, let us know if there's anything else that we can do to help you get set up. Yeah, so it sounds like you guys are all set up in the GitHub and in the Discord. So yeah, and then I think we just need to execute on the transaction to fund the multi-sig. So that should be coming in soon as well. So yeah, great. And hopefully we can get Roy in here next time with his audio. It seems like I saw him mute and unmute, so I see he's there, but might just be an issue right now with his setup.
Yeah, we will test separately. So fortunately, things not always working, and thankfully this time I don't have connection issues.
Yep. Okay. No worries. All right. Well, thank you very much. All right. Cool. Well,
Okay.
thank you, Ron. All right. So we have Celestial Commons. Oh, I know him by his username, Degen Morrison. So he actually cannot make it because his son is sick, unfortunately. So he's taking care of his kid. And then Alex from ASRI also could not make it, but I can give at least one update on their behalf. So they have started a campaign for supporting the mice, and I think that campaign just kicked off yesterday. So they're moving ahead and collecting contributions directly, and then yeah, are still kind of working towards a fundraiser with MoonDAO. And then lastly, Kara, who also could not be with us today. I do not have updates, but I know that she is coordinating with Ryan at the moment. So yeah, maybe we'll hear more from her project next week. But yeah, that's all that we have. So yeah, we can close up. Thank you, everyone. Thanks for joining, and see you next week. Thank you, everyone.
Welcome to MoonDAO, a revolutionary governance model and mission-oriented community that's reshaping collaboration in the space industry. Our mission is to create a self-sustaining, self-governing settlement on the Moon to act as a launch point into the cosmos. MoonDAO is governed like a nation, with its own economy, constitution, voting system, treasury, elections, and senate. But internet native, and so without the limitations of geography. In 2022, we sent our first member to space, showcasing our model's capacity for real-world impact. Now, we're implementing key solutions for global collaboration in the space industry. We offer a borderless, permissionless platform that enables everyday people to participate in the future of space development and exploration. Be part of our lunar legacy and join the MoonDAO movement today.